Welcome back to my channel Electronic Science Tutorial. Today is the 10th class of my operational amplifier. Today I will discuss the differentiator circuit, and from this circuit how can we calculate the voltage of the differentiator circuit. So without any time waste, let's start our class. This is the differentiator circuit diagram by using an op-amp. Here we use one capacitor and one resistor. The one end of the capacitor is connected with the input voltage and the other end of the capacitor is connected to the inverting terminal of the op-amp, and the resistor is connected between the output and the input channel of the op-amp. The non-inverting terminal has to be grounded. So this is the differentiator circuit. This is the input path and this is the feedback path, and this non-inverting terminal has to be grounded. So how we calculate from this circuit the voltage gain? Here we solve. Okay. So this circuit gives an output voltage V0 which is proportional to the derivative of the input voltage V1 with respect to time. Therefore, this circuit is called as differentiator circuit. Okay. First, we know that the capacitor, when we connect one capacitor across the voltage, the capacitor has to be charged. So first of all we have to calculate the charge of this capacitor, because input voltage V1 is applied one end of this capacitor. So how this capacitor charge has to be calculated? That is, the charge across the capacitor is, we know, Q equal to CV. Q is the charge of the capacitor, equal to C is the value or the parameter value of the capacitor, and V1 is the applied input voltage. So the charge across the capacitor is Q equal to CV1 when we applied one input voltage V1. So V1 equal to Q by C. This is very easy. Next, we can differentiating this equation with respect to time. Then what we get? We get dV1 divided by dt equal to 1 by C dQ by dt. Okay. So V1 equal to Q by C, this equation is differentiating with respect to time. Then what we get? We get dV1 divided by dt equal to 1 by C dQ divided by dt. dQ by dt, we know the charge with respect to time, what was to be calculated? That is current. So we can write that is dV1 by dt equal to I by C. Charge with respect to time, when we calculate, this is equal to current. So this dQ by dt is replaced by current, that means I. So here we write dV1 by dt equal to I by C. Now what is the feedback current? Feedback current means, in this path, this is the output channel and this is the inverting input channel. So in this path, what is connected? That is resistor. So when we calculate the feedback current, we calculate the current across the resistor. So the current is I equal to 0 minus V0 divided by R. Why this is 0 minus V0 divided by R? We can calculate the potential voltage drop difference across this resistor. So this is, we know, this point is we know already, that is, this is the virtual ground point and this is the V0 point. So the potential difference is G minus V0 divided by R when we calculate the feedback current, and this G value, that means the virtual ground value, is 0 because the non-inverting terminal is connected with the ground potential. So if we consider G is 0 and V0 is V0, So the potential difference is 0 minus V0 divided by R. So the feedback current is I equal to 0 minus V0 divided by R. So we can write that is current equal to minus V0 by R. Right? Now putting the value of I in this equation. If we put this value in this equation, what we get? We get dV1 by dt equal to minus V0 by RC. Here we put the I value, that is minus V0 by R. So what we get? We get minus V0 by RC dV1 by dt equal to. So from this equation, what is the value of output voltage? Output voltage value is V0 equal to minus RC dV1 by dt. So what we get from this output? The output voltage V0 is proportional to the time derivative of the input voltage V1, and this RC is the proportionality constant. We can control this RC value for the gain purpose, right? And this, why this negative sign appeared here? Because we applied input voltage in the inverting terminal, so negative sign is appear here. So this is the voltage of the differentiator circuit, and from this voltage we can saw that the output voltage is proportional to the time derivative of the input voltage V1, and the proportionality constant is RC. So this is the differentiator circuit, and from this circuit we can easily calculate the voltage of the differentiator circuit by using an op-amp. Okay. Thank you. If you like, do like, share and subscribe my channel.